Hello and Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Nur Hafizuddin bin Khamis, a student for program Chemical Engineering Technology, Biotechnology for BNN, and I am supervised by Dr. Mas Rahayu binti Abdul Jalil. Today I will be presenting about my final year project with the title of Banana Stem as Bio-adsorbent for Palm Oil Mill Effluent POME treatment. Okay, so basically this is my overall view for my final year project poster, which I will be explaining in depth about for each of the section existing in this poster. And the section included in this poster is extract, introduction, objectives, literature review, methodology, results and discussion, conclusion, and the last one is references. Okay, so first I'll start with the abstract section. Banana stem is an agricultural waste where abundance of unusable banana stem can be considered as increase in the amount of agricultural waste. So in order to address the increased amount of banana stem as agricultural waste, this research was conducted with the aim to investigate the potential of banana stem as bioadsorbent in palm oil mill effluent POME treatment, so that the banana stem agricultural waste can be used as an alternative treatment for palm oil mill effluent. In this research, adsorbing capabilities of banana stem as bioadsorbent and various data supporting the potential of banana stem were investigated based on previous literature and findings with the usage of systematic literature review. The banana stem adsorbing capabilities that were studied in this research were focused on the removal of heavy metal ions, reduction of chemical oxygen demand, removal of suspended solid, and turbidity. This is because all of these parameters were main concern in the treatment of palm oil mill effluent. The data obtained shows that banana stem have the ability to absorb heavy metals such as copper ion, zinc ion, and iron ions, which exist in palm oil mill effluent. The data also shows that banana stem bioadsorbent are capable of reducing chemical oxygen demand of the treated wastewater up to more than 50%, and banana stem bioadsorbent are also capable of reducing the amount of suspended solid and turbidity. So based on the results and data analyzed, we can assume that banana stem have the potential to be used as bioadsorbent in palm oil mill effluent treatment. However, further laboratory research and investigation should be done in order to prove this assumption. Okay, next, for the introduction, in agriculture industry, banana is also one of the popular fruit crop in Malaysia. It is stated in the Malaysian government statistic report that there are approximately around 29,270 hectares of banana being planted in 2012, which can produce the yield of banana for around 294,530 metric tons. Due to this, there is abundance of banana stem each time the banana fruit was harvested in a certain banana plantation. This is because the banana stem was cut right after the fruit was harvested, making abundance of banana stem available unused. Since this study was aimed to investigate the potential of banana stem to be used as bioadsorbent in palm oil mill effluent treatment, this will incorporate both of the palm oil industry and the banana plantation industry that were growing rapidly in Malaysia. This is because the project will utilize the banana stem waste from banana plantation industry in order to treat palm oil mill effluent from the palm oil industry. Some of the current conventional technique that was used as a solution for palm oil mill effluent treatment is open pond system, membrane filtration technology, and a technique that utilize coagulation and flocculation process. Thus, through this study, an alternative way of treating palm oil mill effluent can be investigated, and the assumption can be made whether banana stem bioadsorbent is suitable or not for palm oil mill effluent treatment. For the objectives, there are three main objectives to be achieved at the end of this project. The first objective is to study the potential of banana stem as bioadsorbent in palm oil mill effluent treatment. Next is to analyze the content of banana stem that can contribute towards the potential of banana stem bioadsorbent in palm oil mill effluent treatment. And the final objective is to investigate the effect of wastewater treatment with banana stem on the amount of turbidity, suspended solid, and chemical oxygen demand. Next, in the literature review section, I selected 3 main literature that supports the importance of this study and shows that banana stem have the capabilities to be used as bioadsorbent. First, Bijayaraghavan mentioned that adsorption technique is a non-polluting technique, which means that treatment technique that uses adsorption does not lead towards any further pollution for the environment. In 2013, Madaki stated that palm oil mill effluent contains high amount of organic pollutants and small particle solids, which means that it is important for us to find a suitable way to treat the palm oil mill effluent to reduce its polluting capabilities for the environment. In 2008, Cherian mentioned that absorption capacity of modified banana stem is higher compared to the unmodified banana stem. So, the potential and the capabilities of the banana stem as bioadsorbent can be improved by modifying the surface of the banana stem through acid or base treatment. Before proceeding to further explain the methodology used for this study, I would like to clarify that I've changed my research method from laboratory testing of the usage of banana stem bioadsorbent in palm oil mill effluent treatment to another methodology, which is a systematic literature review by collecting data from previous study made to further prove the capabilities of banana stem bioadsorbent to be used in palm oil mill effluent treatment. The methodology changes were made due to current pandemic situation, which caused me to unable to go back to University Tun Hussein of Malaysia to do laboratory testing in the lab there. So I decided to change my methodology to systematic literature review, which can be made at home by collecting data from previous study. For systematic literature review methodology, the methodology starts with the development of research objective. The objectives can be used as research questions, where these studies will be trying to fulfill and answer the research questions at the end of the study. Next is database selection for collection of literature. Various databases for collection of literature were used in this study, such as Science Direct, Wiley Online Library, Google Scholar, Springer Open, Scopus, and Microsoft Academic. After selecting the suitable database for literature collection, keyword selection will be chosen. Suitable keywords for this study such as banana stem bioadsorbent, banana stem content, wastewater treatment with banana stem, functional group available in banana stem, and palm oil mill effluent content were used in this study. After the inclusion and exclusion criteria were developed, manuscript or literature collection were made. The literature and manuscript collection were made by using the keywords selected through the database selected with the help of the inclusion and exclusion criteria. After literature collection, screening process were made based on objectives of this study in order to prevent irrelevant data being analyzed, which can cause unreliability. The collected literature was screened, and literature that contain data for banana stem content, banana stem bioadsorbent, and absorption capabilities of banana stem were analyzed. The parameter analyzed for the banana stem bioadsorbent were removal of heavy metals, suspended solid, turbidity, and chemical oxygen demand, since all of these parameters were important for the treatment of palm oil mill effluent. After the screening process, the final step is data analysis and preparing report. So the data obtained that have been analyzed will be discussed to show the potential of banana stem bioadsorbent to be used in palm oil mill effluent treatment. Okay, next, for the results and discussion section, The data and results were obtained from various studies and comparison were made among them. In this figure, it shows that the percentage removal of turbidity, suspended solids, and chemical oxygen demand. The data for removal of turbidity was shown in blue color, orange for suspended solid removal percentage, and grey color for chemical oxygen demand removal percentage. The study that were made previously were made based on various types of wastewater, such as municipal wastewater, textile industry wastewater, and kitchen wastewater. Overall speaking, banana stem bioadsorbent shows the capabilities of absorbing all three parameters such as turbidity, suspended solid, and chemical oxygen demand. Based on the figure included in the poster, we can see that all studies shows that banana stem were able to remove more than 50% of suspended solids and turbidity in each of the wastewater sample used for the treatment. Banana stem were able to reduce the turbidity value and amount of suspended solid in the wastewater because banana stem are able to absorb smaller particles existing in the wastewater sample, which are the main causes for turbidity and high amount of suspended solid. This was important because palm oil milk effluent contains high amount of suspended solids and have high value for turbidity. So as the banana stem able to absorb the smaller particles in the wastewater sample, the smaller particles will then settle down in the wastewater sample, which will cause the reduction of turbidity value. Besides that, banana stem also contains polysaccharide compounds, which is inulin. Inulin is a natural polymer which can cause bridging and entrapping of existing microfloc to form a much larger floc, which helps in the removal of turbidity and suspended solids in the wastewater treated. As for the chemical oxygen demand value, banana stem bioadsorbent also shows its capabilities in reducing chemical oxygen demand in wastewater. Some of the studies even shows up to even more than 80% of chemical oxygen demand removal by the usage of banana stem bioadsorbent. There are previous studies that shows that functional groups carboxylic acid and hydroxyl exist in the banana stem. These existing functional groups in banana stem were said to be able to improve the banana stem absorption towards organic pollutants and phenolic compounds, which can reduce the chemical oxygen demand value of the wastewater. Due to this statement, we can assume that banana stem bioadsorbent can be suitable in palm oil milk effluent treatment. This is because palm oil milk effluent contains certain powerful water-soluble antioxidant phenolic compounds, and since banana stem bioadsorbent are capable of removing phenolic compounds, which results in the reduction of chemical oxygen demand value, banana stem bioadsorbent may be suitable to be used in palm oil milk effluent treatment. Besides removing and absorbing suspended solid, turbidity, and chemical oxygen demand, banana stem bioadsorbent are also capable of absorbing heavy metals ion that existed in the wastewater sample. Some of the heavy metals ion that are capable of being absorbed by the banana stem bioadsorbent are zinc ion, iron ion, and copper ion. All three of these heavy metals ion existed in palm oil milk effluent. By being capable of absorbing all of these heavy metals ion, it can improve the quality of the palm oil milk effluent so that it can be discharged after the treatment with banana stem bioadsorbent. In wastewater, microbial activity and biological wastewater process can be affected by the high concentrations of heavy metals. Thus, removal of heavy metals from wastewater can also help to reduce the chemical oxygen demand. As for the conclusion that can be made from this study, based on the data obtained, we can assume that banana stem bioadsorbent have a promising potential to be used as bioadsorbent in palm oil milk effluent treatment. The potential of banana stem as bioadsorbent for palm oil mill effluent treatment was shown through its capabilities to absorb heavy metals ion, removing suspended solids, turbidity, and removing chemical oxygen demand of the wastewater. All of these parameters are among the concern parameters and important parameters for the palm oil mill effluent treatment. So, by having the potential and the ability to improve all of these parameters in wastewater, shows that the banana stem might have the potential to be used in palm oil mill effluent treatment. However, further research through laboratory testing for real-time treatment of palm oil mill effluent with the usage of banana stem bioadsorbent should be done in order to investigate the ability of banana stem bioadsorbent in the treatment process, so that the data obtained from the laboratory testing can prove this assumption and support this assumption. So that's all for my final year project poster presentation for today. Thank you.